The code here is for an implementation of a string list user-defined type. Transact SQL doesn't have native support for arrays or lists, or for that matter, almost any other kind of programmatic data container object other than tables. SQL Server 2008 introduced a table-valued parameter feature, but that provides only a table type structure for data. On the other hand, the .NET Framework provides many kinds of data containers and collections. One useful collection is the generic list object, which you can define to be strongly typed to contain only objects of a specific data type, such as a string or a custom object. The string list user-defined type is a wrapper for a generic list collection and exposes some of the properties and methods of the collection and converts types to SQL types as well as handling nulls. All right, so like other SQL CLR modules, you have to decorate the code with an attribute that tells SQL Server the kind of code that you're using, as well as some information about it. For a user-defined type, you use the SQL user-defined type attribute. And it has several required parameters. First is format. This is for serialization, just like previous example. And so this controls how to convert the object to a stream of bytes in order to save it or transmit it across the network. The string list object is going to use a generic list object of strings, so you can't use the format.native option. Instead, string list use format.userDefined, which means that it has to implement the I-binary serializable interface. Okay, same situation as before. The next is byte ordered. When you use a user-defined type as a type of a field or a column, you could sort the rows in the table based on that field, but that doesn't always make sense. The isByteOrdered parameter indicates whether the binary form of the object is in a format that can be sorted. It doesn't really make sense to sort a set of lists of strings, not sort strings, but sort a set of lists of strings. So I've set this to false for string list. Note that this does not refer to sorting the strings within the list. That is a separate issue. All right. Next is fixed length. If the UDT is always going to be a fixed length, then you can set the isFixedLength parameter to true so that SQL Server can handle the type more efficiently. String lists can handle almost any number of strings of any length, so the code sets that parameter to false. And then string list sets the max byte size parameter to -1, which means that its maximum size is 2 gigabytes. Otherwise, you can specify a maximum size for the aggregate. Internally, the code uses a generic list object in order to save the data. And it's a list of type string, so it can only accept string elements. Okay, then I have various sections here with the additional code. And the next section of code handles nulls. A null in SQL Server is different from a null in C# or Visual Basic. So for the UDT, SQL Server needs to be able to determine whether the type is null. So the structure implements the isNull property. And it's read-only. So in this case, all I need to do is check to see if string list, this variable right here, is a null. And then it returns true or false based on that comparison. And then the null property lets SQL Server retrieve a new null instance of the user-defined type. So when I start to use this type within Transact SQL code, SQL Server needs to get a null version of this object. And so it just news up a new instance of this structure and then returns that. Now here's where things really start getting interesting. SQL Server needs to be able to set a value to a UDT as well as return a string representation of the object. For string list, you need to be able to pass a comma-delimited list of strings to the object, which string list parses into the individual list items within the generic list collection. Conversely, It then needs to return the same comma-delimited list when you call the toString method. And so next up is a code that implements those methods. So parse receives a SQL string, and then if it's null, you just return null. Then it's going to instantiate a new string list. It'll split up the string that is passed to the method and puts that in the string array. And then the code runs through this loop in order to trim all the strings so it has no leading and trailing spaces. And then it news up a list object of size sufficient to hold all of the elements within that array. And then it just loops through all of the strings within that strings array. And as long as it's not an empty string, it adds it to the list object. And then it returns that user-defined type. So parse takes a comma-delimited list of strings and returns a new string list object that's populated with all of those strings. And then toString essentially reverses parse. It joins together the comma-delimited list. So if the object is null, it just returns an empty string. Otherwise, it uses the strings join method in order to take this array of strings and concatenate them together with a comma. Join is a really nifty method. Again, it's within the .NET framework that makes it simple to create a string out of an array. Okay, besides serialization, those methods complete the required elements of the user-defined type. But the next section of code just makes the object more usable. Because remember that essentially this class, or this structure, is a wrapper for a generic list object. And the generic list object within the .NET framework has a lot of capabilities. So the code exposes some of those capabilities as public methods of this class, public methods and properties. All right, so the properties that I've implemented are capacity. Capacity returns the maximum number of list items that the string list object is currently allocated for. The generic list collection manages all of that for you, but you can both read and set this value. Okay, so in order to get the value, it just reads that from that generic list object. And for the setter, it just takes the value that is passed into this property, converts it to an int, and sets the capacity property. All right, then the next one is count. This is read-only, and it returns the current number of items within the list. If the list is null, then it returns a null value. Otherwise, it takes the count using the property of that generic list object and converts it to a SQL int 32. So there you see, this returns an integer, so we have to do a data conversion. Get_at retrieves the string at a specific location in the list. So this is pretty easy. Just use the index value into, you can treat this almost as an array, convert it to a string, and then convert the data type to SQL string and return that value. So you can see how the code is leveraging the existing features of that generic list object. If that generic list object didn't have those features, but we needed to provide them to SQL Server when using this object, we'd have to write a lot more code in order to implement that. But in this case, most of these properties and methods are just wrappers around what already exists on the generic list. Okay, then there's addItem. This adds a string to the end of the list. The underlying list method is actually called add, but that's a SQL Server keyword. By using a different name here, addItem, which is not a SQL Server keyword, I don't have to use square brackets around the name anytime I invoke the method. So I can call it add, but it just makes coding it within Transact SQL a little bit less convenient. Okay, so if the current object is null, then it news up a new list object of size 1 because I'm going to have a single string to add to it. And then I take that new string list and add a string to it, and then return that so that the calling code has a reference to that object. And then there's a remove@, so we can remove items from the list. And that just takes an index into the location and calls the underlying generic list object's removeAt method. And then finally, clear removes all the items from the list, which leaves an empty, not null, but empty list. Now, I easily could have written a lot more code to expose a lot of other properties and methods. And you can also create custom members as well. But this code keeps it fairly simple. Okay, and then the last part of the code is to implement this ibinary serialize methods. This code is required because, again, I use the format.userDefined parameter on the SQL user-defined type attribute. So the write method, once again, serializes the object into a binary stream. Now this code is a little bit different than previous examples. So it first checks to see whether or not the object is null. If the object is null, it just writes a special flag there for -1. Because what this code is doing is, as the first value, it's writing the number of elements in the list. This makes rehydrating the object a little bit easier. Okay, so I'm writing -1. That way the code that deserializes this object knows that there are no objects and it doesn't need to do any additional processing. Otherwise, if there are already strings in the list, then it writes out the number of strings and then loops through the list and writes out the different strings. So still pretty simple code to do the serialization. All right, then here's the read method. So this is the method that's going to process the deserialized object and create a new object in memory. All right, so the first thing it does is it knows that there's an int32 at the front, so it reads that value. Remember, that was the first thing that we wrote out there, either -1 or the count of strings. If it's -1, we're done. We don't need to do anything else. Otherwise, if the count is greater than -1, it news up a new generic list object and then loops through all the strings and adds them to that object. That's all the code implemented in this a little bit more complex SQL CLR code module that implements a user-defined type. So then you can build and deploy this code to whatever database that you want to use. And I've already done that. So we can go over here to Management Studio and test the code. Okay, so here's the code. I first start by declaring an array that's going to hold that string list. And then I just create a comma-delimited string that happens to consist of some of our dog names. Okay, so that's the value of the array. And I print out that as a string, just to kind of keep track of where we are. And then I'm going to add Jewel, another one of our dogs, and add that so it's exercising that add item method. And then it's also going to test the toString method and print that value out, and then use some of the properties to look at the different characteristics of the list at this point in time. So it'll display the count, the capacity, and then get the dog name at a specific location. It'll use the count and then back off 2 in order to retrieve the dog's name near the end of the list. Remember, we implemented removeAt, so we can remove the dog at index 3, and then once again print the string. And then we can call the clear method, and then after that look at what the count is after we clear it. So when I execute this code, you can see that the initial string list is Marty and Dosie and Chanel and Raja and Izzy and Chance. We add Jewel, so Jewel is now the last string there. And then we retrieve the count, that's 7. Capacity is currently at 7. That could be a different number, particularly if we remove strings. And then we want to get the dog's name at that location. So as you can see, it's Chance. And then we're going to remove the dog at index 3. So now instead of Marty, Dosie, Chanel, Raja, Izzy, Raja is removed. And then the code clears, and the count is now 0 because there's no longer any elements within the list. In this example code, I created a variable of type string list, But you could also very easily use the user-defined type as the type for a table column.